So, ladies and gentlemen, is the UVC curing also suitable for overprint application? This is a question that we want to answer right now. UV coating systems are, of course, very popular, right, in the printing world because they dry quickly on one hand, they're very high gloss levels, and they have very good mechanical and chemical resistance. But on the other hand, they have a major disadvantage. And this is the fact that the procurement of raw materials is difficult. So therefore, it makes totally sense to test new applications and to test new hardening technologies such as UVC curing. But what is it all about? Well, is the technology also suitable for your kind of application? Let's try to find the answer together with Weilburger Graphics. They have carried out a feasibility study in cooperation with IST. And I would like to welcome now Markus Klopf from Weilburger Graphics. Hello, good to have you here with us.
Maxi, thank you.
So, yes, you provide us with the answers, right?
Yes. I think we can start. So thank you for the introduction, Maxi, and let me say hello to all the visitors to the UV Days 2021. Can you hear me?
Yes, we can hear you. Please start.
Okay, thank you. So let's start with the presentation. So what was the question we have together with ISD? We ask us, is it possible to use the UVC light for overprint application? And also, is it possible for us to reach realistic production speed? Before I start with the presentation, I would say some words about the company Weilburger and also about my person. Here in this picture, you can see our competence center graphics. It's located in Bavaria, in a small country or in a small town. It's called Geretshofen. I work for Weilburger since 15 years, and nowadays I'm responsible for the R&D department in the lab. Here in Geretshofen, we round about 130 persons, and 20% of them work in the lab. So you can see a big part of our work is for new projects and innovations. Beside the UV coatings, we have a lot of other products. Our main products are the dispersion coatings, the UV lacquers. They make around about 80% of the production volume per year. By side, we have also oil-based print varnishes, flexo inks and coatings, screen printing lacquers, and also adhesives for paper boxes and lamination foil. Especially for UV lacquers, we have UV lacquers for all common applications, for all common hardening systems like HR, LED, excimer, and also mercury lamps. And also we have products for the low migration sector. So let's go back to the topic for today. So what was the motivation and also the background why we make this study together with IST? One of the biggest reasons is the advantage of UV curing lacquers for the printing sector. We have a lot of advantages based on the gloss, the production speed, and also the chemical and mechanical resistancy. The next motivation topic was the GAS classification of the photoinitiators and also the migration potential. And so the final question was, is it possible to formulate a UV curing system or UV varnish without photoinitiator? Here you can see the experimental setup. We started with trials only with binder, like oligomers and monomers, and applied them on a lab cardboard with a 6 micron spiral blade. We cure all the trials at IST with a UVC lamp, 240 watts, and with a various belt speed. And after them, we checked the results based on the double bond conversion and also the chemical and mechanical resistance. On the next foil here, you see our first trials. We start, as I told you, only with oligomers and monomers, but see very soon at the beginning that not all oligomers or standard oligomers are possible to harden by UVC. So we only have a small amount or a handful of oligomers which pure can be hardened by UVC light. So and here also you see the problem that very soon the double bond conversion goes down already at 40 meters belt speed. So the next step for us was to add some photoinitiator, which is not reclassified, so we can use hopefully the next years. And then you see here the binding agent 2 and 5, here the top lines, that we can increase the belt speed dramatically. So for us, I think it's necessary to add a small amount of photoinitiator. The next step, then we use the best two oligomers and make a LAC formulation. So that means we add some additives and also put the viscosity to a ready-to-use level. And you see here with this formulation and also with let me say a small trick, we catalysate the binders also, and then we can increase the belt speed very high. So as you can see here at 100 meter, we are nearly at over 80% of the double bonds conversions. So that is for us a very, very good result. The next step, then we check also the chemical resistance against standard UV varnish we use for flexoprinting. It's 360859. This here is our standard varnish. We compare the different belt speeds, and here we have our two best formulations hardened by UVC. And here we see a lot of benefits also based on the chemical resistance of the new drying process. So what is the conclusion for us? What are the results? We can in general cure the UV varnish without photoinitiator, but we see when we put a small amount of photoinitiator, we can increase the drying speed dramatically, and that means for us, for a let me say realistic production speed, it's necessary to add some small amount of photoinitiator. In general, the means can be used for overprint varnish. Another big benefit is that there is no inert gas necessary, so you can use the UVC lamp without inert gas. And at the end, you have advantages in terms of migration and technical performance. And the next step now should be more line trials to see is it useful or usability on printing machines. So thank you from my side. Now we're at the end of the presentation. If you have further questions, do not hesitate to get in contact with me or also the colleagues from IST. Thank you so much.
So thank you very much for your engaging presentation.